Welcome, everybody. We're going to be working on Unit 6 this evening, and we are going to start with covering the concepts required to do subqueries and basically learn about what subqueries are, how they're used, why they're useful, the several, honestly, different formats that subqueries can take because there's no like one direct way to do them. And I think that that's really kind of an important takeaway here. Also, if you learn how to do SQL code in other environments, so like if you've learned like SQL Server, for example, or some other traditional database system, there are some nuanced differences between doing it in MySQL generally versus what we call like T-SQL in a Microsoft world, etc. Um, but I'm going to try to incorporate all of that in here. Remember, our focus is MySQL because that's the database engine that we're using. If you were to use SQL Server, which is the big Microsoft product, another very, very popular choice, there are, like I said, little syntactic differences in how you might approach this. So I'm just trying to be mindful of that. All right. If you are using our old PowerPoint slides and textbook, which I think I've provided information. There are slides here that you can use for reference. We're not using that book anymore, but it is chapter 7 in that book if you're curious. I'm going to begin by looking first at some commands from W3 Schools. And real frankly, I think maybe I don't even need to borrow the links. They're probably pretty easy to pull up here in Brave. But the first one that I wanted to look at before I start, formally talking about subqueries is this command called in, which is basically kind of an extension of the where clause is really kind of a good way to think of it. So it says the in operator allows you to specify multiple values in a where clause, right? And when we first look at subqueries, that's where we usually place them. And that's why I start with this command. So my habit, and I think a lot of other database people, is when they do subqueries, is that in tends to be kind of like the go-to keyword in spinning up a subquery. And I also want you to look at this little piece it says here. It says the in operator is a shorthand for multiple or conditions, meaning not multiple or conditions, but basically or is a state of checking for true and false. And in an or scenario, only one of the factors needs to be true for the statement to be considered true. And in many cases, what a subquery is going to do for us is it's going to create a true false state. So, like, is there data in the subquery? Well, if it's true, then let's take a look at it. If it's false, well, it's not going to work, right? And so, this is indicating to us that a where clause can still have a regular condition to it, and it can have a subquery. So that's kind of where the complication comes in. But in general, here's the syntactic basics, right? So we have a standard select statement. We pick our table, and then we indicate a column name, and then we indicate, is this column part of these values, right? And that is going to return true potentially for one of those values and trigger the statement true to be able to pull the data. And you'll notice in the second statement, and this is where you see a subquery, right? So instead of like looking for specific data points, instead we have a separate query that operates that generates its own data. And I want you to remember this. Whenever there's a select statement and it's pulling data, it's generating tabular data as its output. So in other words, this select statement will generate a table, just like this select statement will also generate a table. So in other words, I have a separate query here built into my query. That's why we call it a subquery. And we'll talk about the terminology of this as we kind of move forward. But when we have a select statement or a query basically inside of another, this one here would be considered the inner query, and the outer one that holds it is the outer query. this query would technically operate first before the outer query can execute. If you think about it, it's logical. But if this is returning a table of information, then we can check to see if it's returning results, then the or condition in the in becomes true, right? And this is probably one of the more common approaches to kind of writing subqueries, real frankly, and that's my tends to be my go-to. I'll just put it like that. All right, so we do have some demo database stuff here, and they give an example. So in this example, they would be selecting everybody from the customers table where the country is in, and so this is just using values now. This is not a subquery, mind you, is included in this data set. So if you hit a row in the table and the country is Germany, or the country is France, or the country is UK, and you see how I said that? Because if you're a customer, you can't be in all three countries. You're in one of them. So only one of them has to become true in an or statement in order for it to return the result. So any customer in Germany, France, or UK would come back in that query result. All right. I do want to also point out that we can run the in command, which is looking for the data, or we can run the not in command, which very intuitively is the inverse. So this would give me all the customers that are not in Germany, France, and the UK. So every other country would be the result on that one. If I was to expand this now to a subquery, and I want you to think about how this one might operate, and this one will actually click through and try it. So once again, I'll select all the customers from the customer table, or all the columns from the customers tables, technically, where the country is in. So notice we're still using the keyword in here. There are some alternatives, and those are the other keywords that we'll look at, including exists or any and all, and sometimes you use symbols for this as well. Just be mindful. But then we have this. It says select country from suppliers. So this is just going to go into the suppliers table, right? That what I have highlighted, pull back all the suppliers, and as long as there's a result, right, something comes back. Well, then we will look at those. So let's take a look at what this might output, because it might be a little bit different than what you're anticipating. So let's run the query, and then you'll notice what it's doing. It says how many records is it actually pulling in? All right, and I'm going to scroll all the way to the bottom, right? And we have 90 records. How many customers do we have? So in other words, and I want you to think about this, as long as the customer has a country declared, this will have a result. And as long as that has a result, then it will select all those customers. So if I had a customer that was missing the country info, so for example, let's click into customers and let's just look at the data really quickly. Is there anybody here that's missing country information? And you see, I'm trying to scroll kind of slowly here, but are you seeing any missing country information? Yeah, that's a pretty easy answer. So all of these would come back as a result. However, if that piece of information was missing, that would be excluded from that. That's kind of the point, right? So you can run a query to help narrow down your query is kind of a way to look at it. All right, let's move to the next keyword, which is exists. And this is an important one, because this one is really designed specifically to work with a subquery. That's its whole point, right? And let's read the description. It says, the exists operator is used to test for the existence of any record in a subquery. And I want you to think about this and compare and contrast it to the in keyword, right? It's very, very similar. All right. Notice it says the exists operator returns true if the subquery returns one or more records. Okay, so we just need one to return a result. So in other words, we run this query whatever that happens to be. And as long as it returns one result, right? And why might it only return one? Because of the where condition, basically. And then if that result happens or exists, then the rest of the query will operate. Right. And so they have the demo database here. They have a products table, a suppliers table, and then if you let's look at their example, right? So they're going to select the supplier name from their suppliers where exists this statement being true. So in other words, they'll look at the product name from products where the product.supplier ID equals that. So there's a connection between the tables, right? So this is spanning tables. And there's a price of less than $20. So if we have products that are less than $20 from the products table, then we'll look at the supplier name for those products. So let's just run that and see what it does. Right. So without looking at the data, right, it's just giving us a list of suppliers that has products that cost less than $20. Right. So this is the supplier's name. And you'll notice it's returning 24 suppliers, but there are 29. Right. So it's not including all of them, but most of them. Right. So that's how that works. So exists. Now, for example, if let's say this condition never hit true, right? So first of all, it has to match the IDs here, and the price has to be less than 20. And both of those conditions have to be true. But if we don't get any results, then the whole query will not operate. There will be no return to the example, right? So I think that's pretty interesting. And then notice how this one is just a revision of the previous one. And instead of looking for product less than 20, now they're looking for one that's exactly $22. Right. And that might be possible. It might not be possible, but that seems like you're looking for a very particular product. And then you want to find out who its supplier is. Now you can select more columns to display. This is a very simple output, but that's basically how that operates. Right. So exists basically looks for the inner query or the subquery to come back with a true result in order for it to operate. All right. The next statements here that we look at are these keywords, any and all. And these are, and notice the definition, it says allows you to perform a comparison between a single column value and a range of other values. So this is kind of an interesting difference, right? So first of all, looking at the any operator, when we use it, it will return a Boolean result. So it'll return a true false and returns true if any of the subquery values meet the condition. So kind of like exists. You can think of it like that, right? So we have anything that matches it, right? So any is sort of like exists, but we only need one result to flip it to true, right? And so this is in its generic form. You'll notice that the where statement's a little bit different. So they have a column name, an operator. So for example, less than, greater than, equal to, something like that, like, something like that. And then the keyword any, and then the query, right? So you can think of really that inner query or the subquery as being part of the where clause, but it's a qualified where clause, right? And notice the operator must be a standard comparison operator. So equal, not equal, right? Also not equal, greater than, or equal, less than, or equal. Right. Then we also have the all operator, which is related, right? So this is why they're in the same area. Also returns a Boolean result, so true or false. And this one will return true if all the subquery values meet the condition. If there's any that don't, then it's not going to work. Notice that it's usually used in combination with a select, where, or having statement, often combined in this general format, right? So all means that the condition will be true only if the operation is true for all values in the range. So if one is not meeting true or doesn't have a value or whatever, it's not going to have a result. Right? If you use all with where or having, so this would be the subquery approach, right? So all can be used with a regular query as well. But in the subquery, notice, the column name, the operator, and all, and then you return your query. Once again, they talk about the same operators here. Same database example. So they have a products database, they have an order details database. And here's an example of any, right? So in this case, they're looking for a product where the product ID, any of them, would meet this query, right? So I know that some of you might be clever, and I'm hoping that you're asking this question to yourself where you could say, could I not just do a direct where statement to pull that information? Yeah, and if your brain's going there, it's going to the right place because yeah, you could write a query without a subquery where you're looking for, quantity of 10 from the orders detail table and you do a join in the process. But notice what's kind of neat about a subquery is we're basically doing a join of this table and this table, but we're doing it through a subquery instead of crafting an inner join or a outer left join or any of that kind of weird stuff, right? So some people like this approach because it makes the joining process in a sense smoother, all right, so that's one approach. So you're only going to pull back any record where the quantity equals 10. I'm just going to go ahead and run it. It's easy enough to run, so let's just see that. So supposedly any of these have a quantity of 10. Okay, so we have to take that on faith. All right. All right, another example here where they're looking for a product ID that equals any of them that have a quantity of 99 or more. So that's, a different approach, but same concept. And then they just kind of keep ramping up the concept. With the last example, and they make a point of it, this will return false because the quantity column has no values larger than 1,000. So this one won't even run. So it won't have a query result. You'll just get an error message for it. When we do the all examples, I'll skip over this approach. That's not really quite so relevant as this one for our subqueries. But for this one, we're looking for the situation for the product idea where all of them equal the quantity of 10, right? Now, if the order, what's the likelihood of every order in our database that somebody ordered 10 of something? Highly unlikely, right? So if I run this, the result is 0 records, right? Because none of them will match this criteria because we're looking for all the records to have that, and that's just not the case. If I use like less than or greater than, I would probably get some results. So let's just try it with like a greater than, for example, and see what kind of results it pulls in. Okay, where are all of them greater than 10? No. Right, so the same criteria. If I were to switch the keyword to any, now I might get some results, right? So there's 77 records where there's any of them are over 10, but the all one is very restrictive. You see, so that one I would generally say be super cautious in how you're using it because most likely it's going to be an unusual scenario where everything, trips the trigger on it. Okay, I'm going to bounce back over to our core shell here for a moment, and then I'm going to go over to this other website. Once again, I'm going to do it in Brave to block all the pop-up blockers and whatnot. But this one kind of looks at this topic and provides a lot of information on a page. It does make a kind of an important distinction here, which I think is useful. And so be mindful of this, that usually when we're thinking about a subquery is we just think, okay, we're doing a query, and then probably in our where statement, we're going to add another query inside of parentheses. And I don't know if you caught that part, you guys, right? So the subqueries go inside parentheses inside of other queries, but they can also be used not only in select statements, but in insert statements or update or delete statements. So you can leverage them in statements other than select. So that's the first takeaway here. Because, technically these three are also queries, right? This one just retrieves information. These have the ability to change or add information, right? So if you're doing a subquery with these and you can be creating or destroying or changing data, you want to be extra careful with how you structure those. But yes, those statements would work inside of there. To just kind of demonstrate like their basic form of a subquery, we go back to the in keyword once again, and you'll notice like their first example is kind of where my brain goes. And this is maybe a very good example of like what I would think of as a subquery, what we're looking at right here. So we're selecting a couple of columns from the employee table where the office code is in this query output. So in this query, we're looking for the office code from a different table where the country code is USA. So this will return some results. And as long as it returns results, any results, right? So notice the keyword again, any, then we will have output of the last and first name of the employees that are part of that office code where they're in the USA, right? They talk about the terminology here a lot, which I think is helpful. So once again, it's kind of a query inside of a query. This is the inner query. The outer query is the one that holds it. This little format of how it's typed up is one I see pretty commonly, just basically to make the inner query stand out as an inner query. They go through the examples here and they show, various examples of inner queries, ones that kind of go beyond some of the basic ones that we've looked at so far. And, so you can do anything inside these inner queries that you can do in a normal query. So if you want to run a function, if you want to do some math, we haven't really done much of that yet, or whatever your qualifiers are, however you build your query, as long as it generates tabular output or a table, that data can be used as data inside this other query to drive the outer query. They kind of keep going on with it with examples here, showing functions, greater thans, and all sorts of stuff. And I want you to notice here real carefully, like in this case, they're not even using a keyword. And this is one of the things I wanted to point out at this site, because, all right, so they're looking at these three columns, amounts one of the columns. And so they have this data that they're pulling from this table. And then they're checking to see, is the amount greater than whatever this query returns, which is, it seems like the average of payments or whatever. And notice the keyword is absent, but the keyword is also implied. And basically, if you think about it logically, in or exists or any are kind of sort of equivalent, right? And in some ways, transposable, right? I have my preferences on which ones I like to use. I was taught within, so I like to use in, and usually I like to teach that one. But I do want you to be aware, just in case you encounter all these words, that exists or in or any or all and what they mean. And then you get these scenarios here where it's not even included, but the query still works, right? And this is one of the challenges of learning this language, frankly, is some of that flexibility, because it retains what we'll call legacy code and modern code all at the same time. If you're not sure how to structure it, I would do lookups of examples but make sure when you look up your examples that you're looking at my SQL code and that it's based upon a recent version of MySQL. So that's a really important differentiator as well. MySQL, and I'm not even sure what the current version number is. What is the current version of my SQL? All right, it's version 8 right now, right? And that's a long-term support version. And I think, and don't quote me on this, MySQL is one of those weird products because I think we basically went from MySQL version 5 to MySQL version 8 or something like that. There was like some number jumping. It didn't go from 5 to 6 to 7. They had in between ones that were basically beta builds or test builds or experimental builds. But 8 is a long-term support version, meaning it's stable and you should build on it. And then if you have an older version like 5 or earlier, there are syntactic differences in the MySQL code. So that's part of it. It tends to be that the modern versions will sometimes incorporate the older, what we call deprecated or no longer used commands, but not always, right? There's always an evolution in these languages, by the way, for the most part. And I'm saying this with a high degree of confidence. SQL as a core language really hasn't changed that much, even since when I learned it as a student. But there are nuances and there are newer things, and it is version dependent and platform dependent. So like if you're working on like I said before, a Microsoft SQL server, your commands will have nuances that are different than MySQL. If you're working on an Oracle system, there'll be little nuances that are different. The core SQL commands, like select, from, where, those types of things, those are very consistent from between all SQL versions, generally speaking. Now, we are going to talk about some other things here, which I think are kind of interesting, and I'm going to kind of dig into this a little bit. But when you read up on this stuff and you start like playing with the code and adjusting it, just remember that you have these reference sites that you can go to and look at the material and absorb it. And don't forget that you have LinkedIn Learning as well. And remember, focus on the current version of MySQL. So if you're doing like a lookup online, so this is kind of my caution, I guess, because we're on the cusp of the midterm here, and people will take their test online. And yes, you can Google stuff because I can't really stop you from doing that. And you look up answers, right? And people will do that. You have to be really cautious that when you look up answers online related to code, that you're looking at answers that are recent and relevant to what you're asking. So a simple select statement is probably going to be the same in all versions. But if I was doing something a lot more nuanced, or using a new feature, or asking a question about a feature maybe that's been deprecated, and I do a search online, be mindful of like the date stamps, like on a Stack Overflow chat. If it's from 20 years ago, it might not be so relevant now. You know what I mean? In fact, I might say if it's a year old, it might not be so relevant now. That's how quickly technology can change. Okay, that's kind of my overall lecture part of the night in terms of what materials we're going to go through. And we will get to tweaking some of the exercises and playing with some of this stuff. But I also want to talk about the fact that we are currently using this product, MySQL Workbench, to do our work. And one of the reasons we select it is this product is created by the people that create the MySQL database. So, I mean, it sort of makes sense. It's like, if you buy a Ford truck, you buy Ford tools, or Motorcraft parts to fix it, just for example. And so this is a fine database tool that allows us to work graphically and type code and execute the code and see the results and manipulate files and do a whole bunch of things administratively with our database, aside from just being able to write code. right? And it's a very good product. And real frankly, when we launch it and we connect up and we get into the environment, the panels even that we use are very, very similar to other products that from other companies. So, for example, if I was to look at Microsoft's SQL Server Management Studio, right? And I'm just gonna Google that really quick. And Microsoft, and I'm just gonna pull up like some screenshots of what it looks like. So this is basically Microsoft's uh, database product for manipulating Microsoft databases. And this is just a screenshot of what the interface looks like. And you'll notice, very similar to MySQL Workbench, you have this like, they call it an object explorer, but you have all your databases and tables and all your schema structures basically here on the side panel, just like we do. They have a window in which they can code. They have an output window where they can see the results, and then they have some auxiliary side panels, including like properties and yada yada yada. Just like little tools that go with the product usually appear in the side panels over here. So very similar type of layout. And chances are, if you get used to SQL Server Management Studio or you get used to MySQL Workbench, it's very easy to transition to the other system. You learn the little syntax differences and you're off and running. It doesn't really take that much to kind of figure it out, real frankly. However, we have students here at Gateway that are really residing in lots of different IT programs. And for the most part, the students that take this particular class are either enrolled in the web software program or web programmer 1-year degree, or they're enrolled in the AI data analytics degree, right? It's like one of those two pathways. And this is important to both programs, but the way that the coders in each one of those disciplines will work with the database is significantly different, and how they will use these tools. And more importantly, what tool we're going to use. And I want to introduce you guys today to the fact that there are other tools that developers use very regularly to work with MySQL databases aside from these. So, for example, if I was an AI data analytics person and I was working with a MySQL database, most likely, I'd probably use this product, or I would maybe use a tool like Visual Studio Code or other high-end IDE, integrated development environment, that would allow you to look at the data in the database, write code for the database, execute that code, and see the results, just like we do in MySQL Workbench. And a lot of powerful coding tools like Visual Studio Code or Visual Studio or other high-end IDEs have that capability built in to look at a database, connect to it, write code for it, and execute the code. Web developers, on the other hand, when we use databases, we're usually not, frankly, worried about the database work. It's not that we're not concerned about the data like a data analytics person might be, but what we're usually doing is we're using the database to store our web pages or to maybe store the user accounts or the settings for our website. Or if somebody comes to your website and types in information into a form and hits submit, where does the information go? It might go right into the database. So from a web developer's perspective, we usually deal with, frankly, simpler, streamlined databases that maybe only have a few tables. And once we get the databases connected to our web application and reading and writing data, we're good. And then we walk away and we leave it alone. Right? That's typically what web developers do. So they're not usually mired in the structure of the data, building the data, updating the database, and doing a lot of the types of manual queries that we're doing. And in fact, usually when a web developer will do this, they'll write queries and insert them into their program code, whether that's done in like JavaScript or PHP or C Sharp or .NET or whatever your coding platform is. And then your web page code basically executes the query and gets it to work, right? And here's the secret sauce. Most of the internet runs on what we call dynamic websites. And most of those dynamic websites have MySQL as the database behind them that stores all the data for the website. And I think this is pretty fascinating. Now, that gives us, or those that are web developers, kind of like an interesting issue, right? Because like we're usually not going to work in MySQL Workbench, but if we're working on a hosting platform, so like if I'm hosting a website, what most web hosting platforms have is this tool called PHPMyAdmin, which is a free piece of software that runs usually on a Linux or Windows server as a separate standalone application to access the MySQL server usually located on the same system. Now, for any of you students here that are web developer students, and I'm just going to do this for those that are not, we have a web server here on campus that we call Prometheus, and this is its homepage. And if you're a web developer and you haven't like done any web classes yet, well, this is the server you'll be working on. And so we have this Prometheus server, and it runs students' web pages and students put their homework here. And because we also teach dynamic web development, we also run a MySQL database on top of this system. So there is a database on here. Some of you may have also at some point worked with the Apollo server, which is the predecessor to Prometheus. So this one's still up and running, and it has been now for about 10 years or so, and it still works. So we keep it running. But you'll notice the different aspects. And usually people who are using this server these days are either web students using it as a backup because Prometheus is down, that's pretty rare, or students usually in the CSS program that are learning how to code in Python and do bash shell scripts. But both of those servers do have databases attached to them. If you're a web student, at some point we will create a database account for you, and then you can log in to that database. And this is where it's cool. A similar tool is what we have in MySQL Workbench, but this is browser based. So this works inside of a browser. And the reason we teach this to students in the web program is because when you go out and you work in the field in web, chances are if you're interfacing with a database, this is the tool that you're using. Now, I'm logged into the database as a root user, power user, the master admin, or whatever you want to call it. So I can see everybody's databases on this. So these are all like database accounts with databases attached to them. And just for example, I don't know if I have any databases in here. I do. This is one of my accounts, by the way. But for example, if I'm building a database, this one is for the back end of a WordPress installation. A WordPress, if you're not familiar, is a data or it's a content management system technically that runs websites. And the secret sauce to WordPress is that it stores basically all of its information inside this database. So every time you post something on WordPress, or you create an article, or somebody comments to something, all of that is stored in here as data, right? Directly. Now, because you're in a database, these are all tables. So for example, if I look at the posts table, these are some pretty complicated tables, but I can look at the data, I can edit the data. And then if you notice, I can look at like the structure of my database table and notice, there's data types declared, right? The collation, is null allowed, right? I can also manipulate the database structure from here. So if I want to get rid of a column or change something or whatever, I can do it graphically through a web browser right in this interface. This is pretty interesting, actually. Now, the other aspect of this, which is cool, right, is this also has a coding window where I can type the same kind of SQL code that I type in MySQL Workbench, but it'll apply to a database on a web server somewhere else, right? So the difference between how we're working now is we've installed MySQL Server on our own machines. So our own computers are acting as the server. In this approach, Prometheus, right, is the server that sits on campus in between rooms T301 and T307, if you're curious, in that closet there. It's in the rack. Actually, that's not true. This one's okay. Apollo is there. Prometheus is out at the IMET facility out in Sturtevant. It doesn't really even matter where it is. It's all in the same network. But I can write a SQL command here that will query that database there, and I can get the results back here in this window. What's kind of neat about this tool, real frankly, is it has all these ways where I can kind of like build, queries quickly. It's got like these like pre-built columns here that I can. So what column is in this table? I don't remember. Oh, they're right here on the list, right? So it makes it really easy to kind of write your code. This is very, very useful for web developers, right? Like I said, most web developers usually don't mess a lot with the SQL code, but if you needed to, this is where you would do it. And the other thing I'll say for web developers in particular, this is, probably the database tool you'll use the most in your career. It's certainly been the one that I've used the most for doing web work. And for the most part, you don't have to futz with it until something breaks. Or, for example, another kind of like funny little anecdote that I tell people is like, this here is a database for a WordPress installation. You'll notice that one of the tables here holds all the user accounts for WordPress. And I can see here, this is the actual data in there. There's only one user on this one. And you can see what the user login is, the password hashed, right? So this is encrypted, but there's the password, the nickname, the email address, and all this stuff. Interestingly, how I learned to use this tool initially is because once I had installed WordPress and lost my login, and then I'm like, oh, it's all encrypted. I can't change it or fix it. I'm gonna have to uninstall, reinstall. And then I did some reading, and what I discovered is that I could come in here, I could edit the entry, and all I had to do to inject a different password in was to figure out what algorithm they use to do the hashing, and then take my preferred password, rehash it with the correct algorithm, and then drop it in here and then unlock WordPress, right? And so the reason I figured that out is because I was dumb and didn't keep record of the password and lost access administratively to a website. So it's kind of a hack, real frankly, like it's not something you really want to share with the public that's doable, but it is known knowledge. But this is also one of the reasons why websites need to be secure, because if somebody can get into your database, they can hijack your website, basically. Or if they can get into your FTP account, same thing. I do find that this is really pretty darn cool, though, as a tool, especially considering that if you wanted, and I'm just putting it out there, if you know that you already have a Prometheus account and you've taken like the PHP class, or any class where we do database work in the web program that includes Java 2, PHP, and beyond, you can come in here, you can just tinker with database stuff right inside this environment. The same databases that you load up inside of MySQL Workbench, you could load here, you could run the same queries and see the same results. And it might behoove you to explore this. Now, if you do not have an account here, at some point you will get one. And I'm just letting you know, that's both true for 1-year web students and 2-year web students. AI data analytics people, just so you're aware, we usually don't give you guys databases on here unless we're doing special projects. It does happen from time to time, but typically we use databases that are either localized or we're just given data dumps of data. Knowing that this tool is out there, though, is really important. So whenever you get into the professional world of doing web development and you're out there, doing anything related to a database, your hosting platform, as a rule, will have this database tool installed. And this, I think it's almost a universal truth on just about every database system. That's how well-known and reliable this tool is, by the way. So it's called PHPMyAdmin. And once again, if you guys are web students, if you get into our PHP class towards the end, you usually get an account. Or if you get into the Java 2 class, that's usually where we introduce the accounts. This would be different than working with MongoDB if that happens to be one of the systems that you're working on. All right, that's going to end the lecture stuff for the evening, I think, but I think I actually have a little additional info here. So I'm going to kind of scroll down here. So I apologize. I thought I was done, but then I remembered, hey, no, you're not quite done. I did a little asking of, I think this was a chat GPT output, real frankly, that if you could like summarize for me, I had to adjust a couple of things in here, real frankly. I didn't like the way it worded it. To describe what a subquery is, how they work, and some, like better ways to utilize them, right? So they give an example of how to use a subquery in a where clause, how to do it inside of a select clause. You can do it there too, right? And I'm not sure how well you guys can see that, so I'll zoom a little bit. You can also put it inside of a from clause. So like if you just have the mindset that it's just going to go in the where clause, and I would typically say that's the most typical usage, right, for it. It is possible that it can go in any part of the query in actuality. Subqueries always use parentheses around them, right? And that, in essence, what that does code-wise is it ensures that that runs first and then the outer query runs, one of the reasons. They also suggest that you alias your subqueries, especially if you're in the from clause, so that you know what data you're looking at. I will be frank, I'm not usually doing that when I'm writing them, but I see why they say that for the from clause. And it says avoid correlated subqueries and possibles. And what they're trying to point out is sometimes it's actually better to use a join, like an inner join, than it is to do a subquery. And I think it's really more of a matter of efficiency. The keywords to use when doing this stuff are in, exists, or any, and we saw also all. But the three typical ones, right? And these, in my mind at least, are kind of interchangeable. I see all three of them as equivalent. My go-to is in, right? They talk about correlated versus uncorrelated subqueries, and a non-correlated one executes one independently, right? A correlated one executes once per row of the outer query, referencing the outer query values. And this is really kind of more about the mechanics of what's happening behind the scenes. But generally we think of it as operating as the second scenario there. All right, here's some just final little summary information. Like where, what type of subquery you're doing, and then where you place it. For the most part, we're looking either, usually at the top two options, select and where, or just where is where we put those subqueries. And I would say most common is this second one that's listed here. All right, I'm going to pause, or actually I'm going to stop the recording here because that ends the lecture part of the evening. So, and then we're going to take a break.